Alright, time to get this little review done. Each of these sequences, start with writing it out, get your common ratio or difference, and then I'm going to jump over to this side before trying to get, the 10th term or whatever one's asking for, just because it's easier to get this when you have the explicit function, because you just plug it in. And so here I notice it has a pattern of multiplying by -3, and so to get my next one, I take 54 and times by -3 to get -162, and then I take that and times it by -3 to get positive 486, and I take that and times it by -3 to get -1458, -1458. Well, I already found out that it was multiplying by -3, so that's the common ratio. It is going to be geometric because it has a common ratio. And now I'm going to do the recursive function here. I'm going to use just sequence notation. It's times -3 every time, so I'm going to do -3 times a sub n minus 1, and then a sub 1 equals my start value of -2. The explicit function, I'm going to do this one in function notation. F of n equals -2 initial value times -3 to the n minus 1 power. And now that I got that, I can plug in 10 into my function here, put 10 right there, and calculate. And when you do that, you basically got to do -3 to the 9th power, to the 9th power will give you a fairly large number, and then you times that by -2, and that will give you 39,366. And ta-da, that's our 10th term. Number 2, this one has a pattern of subtracting 5 every time, so it has a common difference of -5. I gotta do just -39, and subtracting 5 every time, so -45, -44, man, -40, 49, sorry, it's really close to the top of the top there, it makes it hard to write, 49, and since I know it's a common difference, my my type here is going to be arithmetic, and then I'm going to do the recursive formula for that. I'm going to just do sequence notation, a sub n minus 1 minus 5, and then a sub 1, my initial value, is going to be -19. The explicit function, again, I'm going to just put it in sequence notation because I can, basically. A sub n minus 1 minus 19, and really it's really similar to the function notation, except instead of having n and n minus 1 in the function, oh sorry, I messed that up here, man, I always do that when I switch. This should be n minus 1 minus 19. So there's the explicit function, the a sub 12, whoops, that's not 12, 12 is going to be, well, the answer when you plug in 12 here. 12 minus 1 is going to be 11, times -5 is -55, and then subtract 19, subtract 19 will give you -74, and that's our 12th term. Doing number 3 now, this one's, well, it's just adding 3 every time, so we gotta do 16, 19, 22. Has a common difference of 3. It's an arithmetic type. The recursive function that goes with it is going to be a sub n equals a sub n minus 1, add 3, because the pattern is adding 3 every time. And then a sub 1 is 4. You got to give it a starting point. The explicit function, I'm going to just do it in function notation, so I'll stop messing it up. Your common difference goes in front of n minus 1, and then you add your initial value, and so now you got your function. Once you have that, you can get a sub 20 pretty quick because you just plug 20 in there. 20 minus 1 is 19. You gotta do 19 times 3, and then you add the 4 on the end. Your a sub 20 is going to give you 61. Ta-da! And how many more of these we got? A few? Okay, fine. I'll stop and do the next video.